Well, hello everyone, and welcome to the IMTS conferences. I'm Elizabeth Modick, the editor of GIE Media's manufacturing group of magazines, Today's Medical Developments, Aerospace Manufacturing and Design, Today's Motor Vehicles, and Today's E-Mobility. If you have any questions for our presenters today, please feel free to type them in the Q&A section, and we will answer as many of those as we can when we get to the end of the presentation. First, a little bit of background on your presenters. John Zaya is the product manager Workholding at Big Kaiser Precision Tooling. He holds a Bachelor of Science in Mechanical Engineering Technology from Michigan Technological University. Joining John is Charlie Mitchell. He's a machinist in the CNC machining department at Andretti Autosport. Today's presentation is going to look at how machining accounts for only a portion of the time involved when moving a part from concept to reality. Design engineering, programming, and setting up a job take a majority of the time. But when you're a machinist in a race shop with multiple drivers in 5 different racing series, time is not on your side. Discover how Charlie, manufacturing engineering manager at Andretti Autosport, uses a work-holding system to shave up to 80% off his setup times. And now, John and Charlie, the floor is all yours.
Thank you very much, Elizabeth. Happy to be here, and I think I can speak for Charlie, and we're both happy to present what we've done together over these last few years. Just a quick little background. Big Kaiser and Andretti have what's called a technical partnership, and this is more of a two-way street relationship where rather than just being a financial sponsor, we're more of a partner. And so we provide Andretti with tooling and expertise that we have, and then that provides us the ability to use Andretti to bring knowledge of Big Kaiser to the market as well.
Hi guys, thanks for joining us. Hopefully this will be informative and give you some great ideas. Your imagination is the thing that runs your machine shop and what you do. At Big Kaiser and Andretti, with our partnership, what we do is, even with Chris Kaiser, he'll bring students into the shop and give them a tour of the shop, and seeing the excitement that goes on in the racing world, and also seeing what happens in the machine shop. So from taking engineers' dreams and making them come true and putting them on the race car is a very tight time frame. So I started at Andretti's in 2016, and I had quite a few challenges. It was the beginning of February when I started, and it was only 3 months away from the Indianapolis 500. I had 2 milling machines that I had to get up and running that had actually been sitting idle for about six or 7 months. And I had new software I had to learn, and obviously, you know, every machine is different, so you have to pick that up. And I really didn't have that much time. But when I was taking inventory and going through the shop, I came across a receiver from Big Kaiser, a 2-pallet, a 2-style dual receiver for the pallet system. I knew about this stuff working in the real manufacturing world on horizontal machines with pallets and stuff, but with tombstones. But it dawned on me that knowing that Big Kaiser was a partner, that I couldn't quite comprehend why that receiver was in there, but I thought maybe this can help me in trying to come up with a way of making all my stuff that I had to do, continually improving it so that I could meet the demands of the engineers. And because we have so many different race teams and so many different categories of racing, I had a really big challenge ahead of me. Later on, I decided that I was going to take that receiver and the pallets that I had, and I figured if I threw a 3-jaw chuck and a vise on it and just a 5C collet system, that I'd be able to swap from one setup to another on the machine. As the months went by, knowing that obviously that was 2016 when the IMTS show was going to come up, I was going to be able to meet the guys up there at Big Kaiser. I know a great group of people, very informative, very helpful. But the Indy 500 coming up in May, it made me nervous, probably as nervous as I am right now talking to you, but I'll calm down as we go through this. So what I did was, during the 500, we actually test for a week and then we qualify at the end of that week. And we have morning sessions and afternoon sessions. And I know that the engineers decide on particular geometry of the suspension system on the cars. So what I did was I set up what I needed to do for the rockers, which are they connect the shocks to the suspension of the car. Those things were going to be a critical aspect of the race. So as they practice in session 1 in the morning, they might want a different rocket configuration by the afternoon session. So in the meantime, while they're testing, I'm already working on parts on these machines for the next up and coming races after the 500. So when I get the call in the morning that we need to have a different rocket geometry for the afternoon session, I was able to actually stop what I was doing, toss this pallet on there, run off the geometry that they needed, and get that product over to the Indianapolis 500 to track right down the street. And they were able to put it on the car and do a second session. That worked great all the way up until qualifying. They qualified, and we put most of the cars up in the top half of the field. And we ended up going on to actually winning the 100th running of the Indianapolis 500. My first race in IndyCar, and it worked flawlessly. So later on that year, I went up to the IMS tool show and talked with John and started to explain to him what I was doing. And he said, great, I'll help you out any way I can. Let's do this. So we ended up putting the Unilock system on a 5-axis DMU 50 with a small 50 millimeter table. And the CMX 3-axis machine, I put it on there. And from there, this all took off. And we'll talk about that as we go along. John?
So, excuse me. So one of the things that at that point, I had to learn a little bit about Andretti myself, because previously everything had been kind of done outside of the engineering department. And so I learned a lot about Andretti Autosport as a company. And I had a misconception that there was really only one guy in one, maybe 2 cars. And then, so Charlie explained to me, no, there's this whole other ecosystem underneath the Andretti Autosport name that he's supporting and that he's going to go into in a little bit.
Yeah, some of those cars we have, actually, we represent Formula E, Extreme E, the GT4 America, and the Australian Supercars, and the Indy Light Cars. And then we support 5 full-time IndyCar drivers. And then we have Andretti Technologies, which actually supports other smaller IndyCar teams. So it's a vast group of different classes with different needs as they go along. And Andretti is working very vigorously to the Green Deal, where we actually have the Formula E cars and the Extreme E cars, which are actually fully electric. And rumor has it by 2013, the Indy cars are actually going to have a hybrid system.
So once I learned about Andretti, then this gave us the opportunity for me to teach Charlie a little bit about Big Kaiser. So I'm going to do kind of the same thing, just give you a quick overview. So Big Kaiser here in the US is a wholly owned subsidiary of the Big DAISHOA group. And so we have offices here in the US, Switzerland, Germany, and we are all supporting each other in selling tool holders, boring tools. Big Kaiser here in the US, as well as Big Kaiser in Europe, also sponsors other race teams, but we're all basically technical sponsors in the same manner. So our counterparts in Europe are doing the same thing, where they're providing tooling and expertise in order to make the team work a little better, not just providing that financial aspect that a lot of people have that misconception of. So Big DAISHOA, our parent company, provides tool holders, collet systems. You'll see a little bit later on, one of the key tools that Charlie saw that we offered was an angle head that allowed him to do something really intricate on a new workpiece that they're doing. Another company that Big Kaiser represents is Speroni, which is an Italian tool presetting machine. And so by taking the tool presetter and our tooling, Charlie's able to kind of get things started at the very most basic level and get them working very well, so that he's starting on a very good foot with really good product behind those specific applications. So Big DAISHOA, like I said, our parent company out of Japan, sells extremely precise collet systems, tool holder systems that Charlie is able to take advantage and to be able to make his parts to a higher level of accuracy and a higher level of quality, because he's able to support the cutting tools with a very good tool holder behind it. One of the key benefits of machines that Charlie has at his disposal is that they're all Big Plus tool machine interfaces. And so for those of you that might not be familiar, a conventional spindle and tool interface will have a gap between the front face of the spindle and the tool's V-flange. When you convert that over to a Big Plus tool and spindle combination, that gap is bridged by both the tool and the spindle, and that creates a fit face, a simultaneous fit face that now provides a lot more rigidity to the tool holder, but also it provides more accuracy to the tool and spindle interface. So if you're doing a heavy operation, you can gain the rigidity that you're looking for. Or if you're on the other side and you're looking for more accuracy or more precision, you gain that because now your tool isn't being pulled up into the spindle at higher RPMs or anything like that. So all of this leads to better cutting tools or tools that make better parts. Another item that Big DAISHOA provides that Charlie keyed in on was one of our what we call our slender drive angle head. And this is an angle head that has a very, very small output that allowed him to get down inside of a workpiece in order to drill some cross-drilled holes that are being used on a very cool workpiece that's part of a bigger system that Charlie can go into a little bit.
Yeah, these are actually shocks. It's not a normal shock. It actually has a shock and a damper. They're very high-tech, very expensive piece. We spend a lot of time and effort and money on developing and building these dampers. We call them dampers. With Big Kaiser and John's help, he's able to help me come up with tooling and fixturing that gives me the ability to be able to make the engineers' dreams come true. And this particular tool, the 90-degree small head, I had to get into a very, very small bore and drill a very small hole, a cross hole, and it wasn't going actually outside. I couldn't get it from the outside. And the DMU 50 was the perfect machine to actually machine this part, but I had to get into the hole. And John sent over this 90-degree head, and I put it in there, and it worked flawlessly. It really accepted what we wanted to do. These shocks, we have a dyno tester. We actually put the car on what we call a shaker test, and it vibrates the car based on the knowledge and the diagram that they have on a particular track that they put it on. And we're able to see the curves of the shock pushing down and actually coming up. It's very complex. It's got inertia gears in it. It's like a pump that spins in there and pumps up and generates or energy recovers the energy that's taken into the shock, and then uses that energy to actually dampen the shock or put grip down on the track. That's the big thing that you want to do on these cars, because they're very light, very high horsepower, and you want to get them to run as low as you possibly can to the ground. But any little bumps or deformities in the track surface will actually change, take the car off the track. It will slide. So it's a very crucial part, and Big Kaiser and John are extremely helpful in giving us the equipment, the tooling, and the fixturing, and the knowledge to get this product done.
So the other aspect with any kind of tooling is measuring the tool, because you have to know that specific tool's length offset in order for the machine to use it correctly. And keeping in mind that the theme of this presentation is about work holding systems and setup reduction. Another place where setup reduction can take place is at the tool presetting station. So Speroni, the manufacturer that makes these tool presetting machines that we sell, basically the concept is that instead of wasting time at the machine presetting your tools or measuring your tools, you can do that offline in a tool presetter, and then allow your machine to keep running and doing what it needs to do. Now, where this kind of gets a little complicated is that if even under one roof, you can have multiple machine types with different types of controllers. And for example, Charlie has 3 different controllers that he has to deal with. Each one has a different setup and layout. And so what we're able to do is take the tool's data, the length offset and diameter, and take it directly from the presetter and push it directly to the machining center. And what this does is it prevents you from having errors during the data entry process of getting the tool's length into the machine. But Charlie will go into a little bit more detail as to how this was beneficial for him as well.
So my philosophy is to take racing and what we do, because we chase the clock all the time, and implement that racing mindset and put it actually into a machine shop. So with continuous improvement, you can come up with some really good ideas to actually get your machining cell or your small shop to produce parts a lot quicker. So we look at programming setups, tooling setups, and then actually cutting the first piece and then producing the parts that you need. All that takes a lot of time. I'm wearing all those hats all at the same time. So I had to let my imagination run wild. Plus I had to take the racing philosophy that I have and implement it into the machine shop. So just like we do in the pits, where we work very, very hard at where we stand, where we turn, where the tire goes on, we're able to produce a 7-second pit stop. I look at the machine shop in that same way. If I can build pallets with 3-jaw chocks, 5C collets, tooling plates on it, fixturing that I can use on multiple different parts. I have one pallet that's just a grid of 1/4-20 bolt holes. And I made a bunch of toe clamps, and I'll throw that on there to just clamp a plate on. Now I'm used to having the aluminum plate that's on the table and throwing a couple of vices on it, and you'll see that in a few slides down. But with the Unilock system, I'm actually able to take, like on the 50, that's all I throw in there is the Unilock plates. So I can throw a pallet on there that does that has that grid, and I can throw a plate on it and mill it out, or I can throw the 3-jaw chuck. I even have a a pallet that has a curt 6-inch vise on it. So that takes down the setup time. Then go over to the tool presetter. I'm able to preset all my tools. So I run into my office, I program out the job, I get my tooling sheet, I come out on the shop floor, I set all my tools, throw them on the bench, load in my program, and load the tools in. Now with the presetter, it actually automatically puts it all into the geometry pages of those controls. So there's no fat finger in mistaking or switching numbers around and creating a major problem, especially when you're in that rush and trying to get that continuous improvement of getting that part out as quick as you possibly can. So with that said, I take those tools, I throw them in the machine, I get my program downloaded in there, and because that presetter will actually measure not only the height of the tool, it will measure the diameter of the tool. So not worried about cut or comp, I actually put that diameter of that tool right into the machine. So when I cut that first part, I'm pretty confident that it's going to be within the tolerance or the envelope of the tolerance of what the engineers expect it to be. All of this makes that setup a lot quicker. And by continually improving it and having that mindset of, hey, this is just like a race team. All machine shops compete for jobs. Here in the racing world, we compete for trophies to win, to get the championship. So putting that mindset into that machine shop environment, and if you get all your guys to have that mindset, then everybody works together. So each individual link, like we won the Indianapolis 500, not once, but twice since I've been here. The year after that 2016 win, we went back in 2017 and won it again. What ended up happening was I can't take full credit for that. I did make the rockets and I did get them to the track on time, but it's a link, and I did not want to be the weakest link in that chain. And by using the Unilock system, the big Kaiser tools, and the presetter, that gave me that ability, and it helped me be that strong link to be able to get them parts to the track. Now all the guys have that mindset, so they all think about, where they're going to put their tools in their toolboxes, how they're going to set up when they're actually going to work on the car. And we all know that from lean manufacturing courses that we took. We all know it from continually improving. But to really bring that into your environment, to make that investment and give those guys that ability to be able to do this, it would put excitement into the guys that are running these machines, and they'll actually help you improve that. It's all about getting the parts out. It's all about keeping those spindles turning. And we know that programming, setting up, setting the tools, and getting them in the machine is all work that we have to do. We don't want it to be while that machine's sitting idle. We want to make it so that that machine's running, everything's staged up and ready to go for the next job, and then you load it in. And I know all shops do it, everybody tries to get it done, but actually the last key to that whole thing is I don't want to be sitting there playing around with T-nuts and bolts and studs and bolting vices down and trying to indicate them in. I actually have these pallets. When I make them, I put a machining hole right inside of them, so that when I first put the pallet onto the machine and I get my work coordinates done, we all have multiple work coordinates in these machines. So I'll engrave on that pallet the particular work coordinate that it is, G54, 55, 57, 59. So when I pick up that pallet, I look over, I know I'm going to a G59. I know that when I download that program in there, I just double check and make sure that that G59 is in all the tools, and away I go. It took me a long time. I've been machining for 42 years, and it took me a long time to actually sit there, write a program, run it through the simulator, do all this work and get that part in there, and have the confidence of pushing that cycle stop button and literally walking away from it and going over to the other machine and start working on that. It's tough, but the confidence builds up that because you have all of this backing you up, you're able to have that confidence to actually do that. So we build a better product here at Andretti Autosports to build a better car. So if anybody wants to compete against us, you're going to have to definitely build a better car than we do. And we have teams, we have companies like Big Kaiser behind us to get that job done.
Thanks, Charlie. So some more of the products that Big Kaiser has also offered and provided to Andretti include basically the heart of our company, which is the Kaiser boring heads manufactured in Switzerland, as well as drills and end mills that are offered from another manufacturer that we represent called Sphinx, another Swiss manufacturer. We won't go into too much detail, but these are products that we've offered and Charlie has integrated into the production of almost every single part that he's had to work on. But now we're going to kind of switch gears and get into really the heart of our presentation, which is the Workholding system. Unilock is what we call a 0-point Workholding system, and it's manufactured by a company in Austria that we represent called Inatool. And it's a system composed of basically a different series and styles and types of what we call clamping bases or chucks that are mounted to the machine table. And this creates a fixed reference point or 0 point that allows you to load and unload parts, fixtures, vices, almost anything that you can attach a retention knob onto, you can put it into the system. And all of that provides 5 microns or 2/10,000ths of an inch of location repeatability so that you can rely on the system to take your vise, take your fixture out, set it aside, and then when you need it again, bring it back in and have that location repeat exactly where it was previously. So a lot of times customers will come to me and say, well, why should I implement using Unilock? And it boils down to basically three points. If your company should have a philosophy of process improvement, a continuous improvement process for long-term or short-term products that are being made. If you're looking at fast-tracking R&D or prototyping projects where you can't have a huge investment in something that may not go very far. But also if you're looking to reduce errors, reduce wasted time, reduce scrap material, and also save money. Those are the 3 big points that any kind of workholding system like this will benefit you. And so we're going to kind of take a look through the following slides of different application examples that Charlie and I have worked on over the years so that you can see how we've taken some of these concepts and applied them to the race world, but in many cases, they will apply to any industry, aerospace, medical, automotive, doesn't matter. They'll apply to pretty much any size part, whether it's a small little part or a huge tractor size workpiece, whatever it might be. The concepts are all the same. So we're going to take a look at these applications and delve into them a little bit and give you guys some examples so that you see what a system like this is capable of doing. So this first application is kind of simple and straightforward. It's called a baffle, and it was actually a part of the damper that Charlie was discussing earlier. And it's a small circular workpiece that has a series of holes that are drilled at various angles. And Charlie approached me with a concept that he had been familiar with in the past, which a lot of people use today, which are called soft jaws. This is where you take the hardened steel jaws off of a vise and replace it with soft aluminum blocks that you then machine into it a pocket that mimics the workpiece's profile. So in this case, it would have been just a circular profile. But Charlie knew that this system, this concept, although it works well, it does have some drawbacks. One of them being that sometimes you have to stay at the machine in order to load up the soft jaws. So his initial concept had 8 work pieces, and he thought, well, I think I can do better than just 8 parts. So he tapped me for an idea, and I said, well, I would look at a pallet. And so I came up with an idea, and my pallet had 12 parts. So I was like, oh, great, I got 4 more parts. And then Charlie was like, well, hold on a second. I can take that even further and put 16 parts on a pallet. And so he was able to take my idea, run with it, and implement it, and figure out a way to make himself even more productive.
This is a great story, John, because if you look on that far left-hand picture there with the 8 parts, in order to get 8 parts with that particular part that we're working on, you had to put 2 Kurt vices side by side, throw a long chunk of aluminum up against the hard side, and a long one up against the movable jaw, and then machine those all in. One of the things that I don't like about running soft jaws, and I've tried a couple of different ways with flathead screws and pins, is once you do that job and you mill out all the pockets in that soft jaw, when you take that thing out and you happen to run that job again and you put it back in the vise, it's as much as whatever you do, you're still going to have to take a skim cut on those jaws again. You're still going to have to do it because those parts might not fit all at the same level. When you tighten up the jaws, they might lift up a little bit. So using the Mighty Bite system, and John introduced me to, I knew about Mighty Bite, but he introduced me to Mighty Bite, and they helped me out with the Mighty Bites that you see on these pallets. When I originally talked to John, he sent me this model. He said, listen, we can get 12 in there. Now, the funny thing about this is we went from, this job shop back in 2016 type of environment where we only had 3 full-time teams and we were putting a couple of extra cars on that Indy 500 to now. This particular project started off in late 2018 where we went into Andretti Technologies, where we were actually building these dampers for ourselves. We were going to have our own, not buying a damper and then modifying the parts. We were going to build one ourselves. And in order to do that, we were actually also adding on more teams, more full-time IndyCar teams and more the GT4 teams. So what we did, because of that, we were going to ramp up the production and ramp up the shop, go from average of 5 or 6 parts at a time to 40 and 50 parts at the job. And that made me even more nervous. So they were saying, well, let's throw a second shift on, or let's add more employees. And in the racing world, they just really didn't understand putting a second shift on in a heartbeat is going to be extremely difficult. We don't even have processes in place to be able to do that. Then you got to train people. This is kind of a totally different world. How am I going to do this? And again, I leaned on John. He sent me that model. I took that and ran with it and said, I can put 16 parts in here, build 2 fixtures. Now, when I'm putting this fixture in there, and that's a single little small pallet, I throw it in there. As it's making the parts, I'm loading up another set of parts. And when that job's done, I'm pulling that off. You know the deal. I'm throwing another one in, hitting cycle start. And then I'm actually taking that pallet and putting it on a surface plate that I have a fixture, a Unilock receiver on there. And I'm checking those parts before I even take them out. That way there, if I gotta make an adjustment and throw them back in, I'll just put the pallet off the side. When the other one's done, I make the adjustment, rerun them, and all's good. I'm not skipping a beat in that chain. That I don't want to be the weakest link in the chain.
Yeah, we'll see in a little bit how you can use the Unilock system for measurements in another slide.
Yeah.
But keeping in mind the philosophy of continuous process improvement, even in the 4 years that Charlie has been with Andretti, he himself has also been able to figure out ways to do what he was doing back in 2016, but by implementing a new fixture or new process, he was able to figure out how to make the work pieces, i.e. his rockers, to a higher level of accuracy as well.
Yeah, this is interesting. So if you look on the far left-hand side, you'll see the 2016 setup that I had. Operation 1, the left vise, the center vise is Operation 2, and then the third pallet was Operation 3. The middle vise, I was using the Big Kaiser digital boring heads, and those rockets have 4 different size holes in them, and they're all plus or minus 2/10. The piece is aluminum, and I'm sure you'll understand the problem I ran into. I'd have to put a torque wrench on that middle vise and try to torque it as low as I possibly can to make the boring bars go in there and cut that bore so I'm not distorting it. But I'm still putting it under a restrained condition. And I was still falling out of the tolerance range for the bore sizes, because it would bore it right to size and you'd measure it in a pot. But as soon as you released it out of the vise, of course, being in a restrained condition, it's going to move, especially when you're trying to hold a couple of tenths. What I did is I took a pallet and I put 2 blocks of aluminum on it, milled out that fixture, put a couple of quick clamps down in there. And now what I'm doing is on that operation, when it's doing the final bores, it's actually in an unrestrained condition. I'm pushing down on the top of the pot, but I'm not restraining it around the profile of the pot. So it doesn't distort the pot whatsoever, which gives me a much better product, and I'm hitting the numbers. I'm staying within the envelope of tolerance that I'm allowed for those holes.
Speaking of hitting numbers, a lot of customers that have started using Unilock on their machining centers have also found that another place where they have a bottleneck oftentimes is quality control or inspection. And so one of the things that some companies that have started using Unilock have been doing is putting it in their quality room or on a CMM. And this allows them in certain cases to take the part and its fixture from the machine over to quality, have it inspected, checked exactly how it's being held, and then with whatever changes need to be made, go back to the machine, have it locate within that 5 microns, and be able to make whatever adjustments they need to the workpiece at that point. So as Charlie mentioned, sometimes your numbers in the machine are great, and yes, there's a lot of in-machine probing and measuring going on these days, but sometimes there are features that you might be able to get to with a cutting tool, but you can't get to it with a probe. And so sometimes you got to take the part out in order to take a good measurement. So that's something that we've seen a lot in newer applications with certain customers. But also one of the key things, and one of the main concepts that Charlie has to deal with, is when you're looking at R&D projects or prototype projects. And those are 2 types of projects that you can't really justify a large investment into fixturing and tooling. So sometimes when you want to try something out, you need to have a quick way to do it. And so building a big custom fixture to make something sometimes isn't the best way to do that. And so when Charlie's dealing with his engineers there, sometimes they'll have an idea and they come to him with, okay, we need this by Friday. How can we get it by then? And he'll figure out a way to make it, because he's using the Unilock system behind it, either on their manual machines, like you see in the images here, but also in all of their standard CNC machines as well. So he's able to move very quickly and very accurately between any type of production part, like you saw earlier with the baffle, or with the R&D projects and things like that. But what's also really nice is when you have to deal with customizable parts. So this application is really interesting, and it's a steering wheel, and you can tell it's for all the controls are there in the middle, but every steering wheel is slightly customized because each driver has different hands. And so Charlie will discuss kind of how he's dealing with the fixturing for this type of a part.
Yeah, this is interesting too, but I want to touch real quick on what you were talking about, doing the prototypes and the production stuff. One of the interesting things that happens to me a lot is now that we have somewhat of a production going on, and I try to keep the machines running all the time. I'll have a particular job in there that I'm making parts, and we'll have some sort of emergency job, urgency that we got to get done. It's going out to testing or whatever whatever the problem may exist. What I'm able to do is pull off that job that I'm working on. It'll be on a pallet. I'll just take it off the machine. I'll put a new pallet on there, put the prototype on there, change over my work coordinates, run off that prototype, and then I'm able to actually take that part off and go ahead and put the job that I was running back on there. I thought of that, John, when you were talking about the mills. I didn't realize, I forgot it was the next slide down. But let's go back to the steering wheel real quick. So this steering wheel is made out of carbon fiber. And what we have to do is we got to make what they call a puck. This is blue board that I machine out, and then they make a mold with carbon fiber and then put the carbon fiber in that mold to actually make the pieces for the steering wheel. The blue board chips a lot. I'm sure some people have run it before. It's dusty, it's like chalk. And to be able to hold it in a vise on that small table, that's the DMU50, and that board, if you can see, is pretty large. Again, called up John. I got this big block of chalk that I got a machine, and he said, hey, I got a vacuum fixture here. You want to give it a try? And sure. So he sent it down. That's a clamp that's holding the parallel, and I put 2 pins on the other side of it. So at night when we shut off the air compressor, the vacuum releases, that board just rises up, and then in the morning when we turn on the air compressor, it sucked it back down. And it gave me the ability to actually machine that piece in the DMU50. It was absolutely beautiful. I really enjoyed that particular that fixture. Someday I'll put a chunk of aluminum on there and mill it out and let John know how that works out.
I'd be interested to see that.
Yeah.
So keeping in mind with the R&D and prototyping mindset, as Charlie alluded then to, is that whenever you're dealing with this type of an environment, you're not doing the same thing over and over and over again. You're constantly switching between one part and another fixture and a different fixture. So in some cases, if your part takes a long time to run and somebody comes up to you with an urgent request, the ability to swap fixtures out mid-program or mid-run allows you to not have to delay something else to do something very quick, but allows you to get back up and running to what you were doing very quickly and easily. So all of this, all the work holding that we've been looking at, whether you're in a production environment or a job shop or a race environment, all of it's designed to help the changeover process go a lot faster. And so just to kind of summarize, the three reasons why most companies come to a work holding manufacturer like us is because they're looking to reduce their time, reduce wasted time, save money on fixturing, and make themselves more flexible. Because they've come to the point where they realize that, okay, we are able to make this part in a certain number of minutes or seconds, but every time we have to change from one to another, that's when we're losing a lot of time and wasting a lot of money. Or we don't have our setup guy anymore, and now we have to do things ourselves rather than rely on a single person to do all that setup. So making the system quick and accurate is great, but it's also convenient because now you don't necessarily have to have a dedicated person doing all of that fixture changeover or setup time. And like we mentioned earlier, don't have blinders on to thinking only setup time is at the machine, on the machine table. Setting up the tooling ahead of time, offline, using a tool presetter is a great way to also save time as well as expense, because everything boils down to a cost. And so making sure that you can have that cost reduction as fast as possible with Unilock and with tool presetting and with good cutting tools and tool holders, all of that comes together and is able to make yourself more productive and more attractive to whoever your customer might be. So I think that's pretty much our time. We've got time for questions if need be.
Great. Thank you, John and Charlie. It was some very interesting information you gave us, and you changed gears quickly in the racing business, huh?
Yes, we do.
So we do have a few questions. We have different types of machines. Can this system be used on horizontals?
Yes, we didn't really touch base on different types and styles of machines, but yeah, a horizontal machining center, EDM machines, even grinding machines. The Unilock system can be applied pretty much anywhere that you can use a quick change system to help reduce your setup. So a horizontal, whether you want to talk about the face of a tombstone or the entire tombstone itself, we have customers doing that also.
Great. And another question with the Unilock system, do we have to have the air connected all of the time?
No, that's a very common question. The Unilock chucks are essentially spring closed and air to open. So a lot of people like to think of truck trailers. Their braking system is designed to operate under air pressure to open or release. So we have plenty of customers that specifically, like when you have to deal with a rotating application like the tombstone on a horizontal or a 4th axis indexer, where you can't keep an airline connected, you can disconnect the airline once your fixture is loaded. The springs are always there, they're always present, and they're always clamped. And the system won't open again until you apply air pressure to release it.
John, I'd like to add to that question. I have 2 systems that have the regulator on it that when I change a pallet, I'll run over to the machine. I hang this system off of the corner of the machine. I plug in my air line, and then I plug it into that Unilock system. Drop a pallet in, throw the air off, it locks into place. I unplug it, and I use that Unilock system on a 5-axis machine, and it without a problem. It works very well.
Great. And I don't know which one of you wants to take this question, but how about the 4th axis indexers? Can Unilock be used with them?
Yes, they can. So traditional 4th axis indexers, sometimes customers see that as the secondary operations to a part that's moved from the table or in a vise. Then they got to take it from the vise down to the face of the indexer. And that's pretty common for like a typical 3+2 workpiece that has features on multiple faces. The only problem is that sometimes indexers don't have vices on them. They've got T-slot platters with radial T-slots or linear T-slots. So that means you have to have a separate fixture to hold your part on the indexer. Well, I have plenty of customers that take the part and its fixture plate off the table and go right into the face of the indexer because they've put Unilock on both of those points. And so the interface is exactly the same. They don't have to have 2 separate systems. And that allows them to save that time going between 2 different locations and having to deal with where's the wrench for this, where's the wrench for that. There's no wrenches, they're just the same airline. So you just connect, disconnect, and it's very quick. Interestingly enough, one of the more common uses with indexers is that some customers have to be able to take their indexers in and out of the machine. So if they're doing smaller work pieces, they need the indexer, but then their next batch of parts is going to be a bigger part, then they don't need the indexer, but they need the table space. So we have some customers that will actually take the indexer mount it to an adapter plate with unilock knobs on the underside, and then that allows them to locate the indexer, again, with 5 microns or 2/10,000ths of an inch, repeatability, saving them a lot of setup time whenever they have to bring that indexer back in and out of the machine. So on the face or on the table, unilock can be implemented anywhere, really.
Wonderful. Well, I appreciate both of your times today. It was a wonderful presentation, and for everyone watching, this will be posted on IMTS Spark and available to rewatch at your pleasure. Thank you, everyone, and have a wonderful afternoon.
Thank you.
Thank you.
Bye-bye.